So before we begin with the main training, let me tell you a little bit about Bose Math Olympiad. It starts in August 2021 this year. And for the junior level, the curriculum includes the four topics arithmetry, spatial patterns, numerical patterns, and mathematical imagination. So if you are an internal student of Cheenta, you already know and have seen these topics extensively. You have worked on problems related to it.
Sir, is arithmetry a combination of arithmetic and geometry?
That would be right. Yes.
That is why I say arithmetry.
Yes, it is. So this contest will be very similar to Math Kangaroo and Moems. So if you are a citizen of France or United States or even in India, you might have given these contests, Math Kangaroo and Moems. Requires a lot of imagination, a lot of pattern recognition, and so on. So similarly, we'll also talk about Australian math competition. This year, you can register for the Australian math competition through Cheenta. We are officially approved school by the Mathematical Association of Australia. So you can register through Cheenta. You don't need to be a student of Cheenta to do it. Anyone can ask us for helping them for registration. We don't charge anything, but Australian math competition does have a registration fee, so you can check it out with them as well. This curriculum is very similar. Includes stuff from arithmetic, geometry, spatial patterns, numerical patterns, and some other imaginative mathematics. Also, this one is also similar to Math Kangaroo and Moems. Okay. All right. So with that out of the way, we will talk about some of the tools that you may be using to do mathematics at this level and which will be useful for these two contests. Okay, so there is one topic called paper folding geometry. Maybe you have done it before. We think that this is okay, so there is more people joining. Okay, so we will see that this will be extremely useful for understanding many patterns and many problems. So we'll start with the notion of net of solids. So suppose you have, oops, sorry. One moment. I think this needs to be, okay, here we go. So I will share the board one more time. I think the thing is gone. So let's see. Okay. So I'm sure now you can see it again. All right. So before I go ahead, I can answer a question from Adish Devasthale. Mathematical Circles is a very good book, but it does not contain some of the more advanced topics, or some of the topics, I wouldn't say advanced, some of the topics which would be more geometric in nature. We will cover some of them here. Okay. Okay, so let's talk about net of solids. Suppose you have a cube like this. So a cube is a three-dimensional solid, the one that I'm showing you here. Why don't you draw this in your notebook, just like I have drawn it here? So you have A, B, C, D, E, F, G, H. And you want to think of this as a paper cube. So think of this. This is, you are imagining this as a paper cube. So it's a box made out of paper. What you want to do is to open it up and lay it flat. So you want to open open the cube up, open it up, and lay it flat. So what does that mean? Well, you get something called the net of the cube. In fact, if you do it, you can do this with any other solid figure. Now I will show you exactly what I mean, but I want all of you to try it first on your own, okay? So think about it. What could I mean by opening it up and lay it flat? Laying it flat. So I'll give you a couple of minutes.
You can fold it.
So yeah, I have some raised hands here. So I'll go to, in fact, let me first go ahead and draw a cube here so that you can see it. So a cube, let's draw a cube. So here we go. So I think all of you can see the cube here.
Yes, sir.
Okay. All right. So once you are able to see the cube, let's see what it means when we say open it up and lay it flat. So I will use the net of the cube. So we use this software extensively in our programs. And so if you are an internal student of Cheenta, you are very familiar with this software.
Sir, you got a net.
Yeah, exactly.
Sir, you got a net.
So what is this? This is the net of the cube, as is pointed out by some of the students. And I will tell you precisely what that means. Well, you can sort of fold it up, and so let me go ahead and rotate this. You can fold this thing up. This paper, you can think of this as a paper, and you can fold it up and sort of make the cube happen like this. So if you open this up, you will get the flat piece of paper, which is this cross-shaped thing. A flat piece of paper, which is the cross-shaped thing. And if you fold it up and lay it flat, of course, you get the cube. Okay, that's great. Now, the thing is that you can do this with other solids as well. So let me do one thing. Let me delete the cube and create a pyramid, sort of a pyramid, okay? So let's go ahead and create a pyramid, which is very special. In fact, it's known as a tetrahedron. So I'll go here.
Sir, the tetrahedron has 4 faces.
That is
It's a platonic solid.
excellent. Yeah, of course. So I see that there is this tetrahedron. Can all of you see it? It's sort of on the...
Yes, sir.
So I'll move the graphics view a little bit. And I'll sort of make it a little bit bigger. So you have this cube or a pyramid. I'm sorry, this is a pyramid, but this is a very special type of pyramid. This pyramid has all the faces as what type of object? Can you tell me? What type of...
Equilateral triangle.
Excellent. All the faces of this pyramid are equilateral triangle. Now, what we can do is we can create the net of this one as well. So let's do that. Let's create the net of the pyramid. So of this tetrahedron, I'm sorry. So you have this triangular shaped thing, but of course you can see exactly why this is the net, because if you can sort of it's very beautiful. It moves up like petals of a flower or something like that. So it's kind of nice. Okay, so we have this. Now let's go ahead and use another one, maybe. So let's delete this existing things. And here we go. And we can go ahead and create another sort of a solid, maybe a regular pyramid. Let's go ahead and create a regular pyramid. Like this. Okay, so this is very weird. Let's make this 0.5. This is, maybe I can make it 0.5. Here we go. Zero 0.5 and okay, so we have this weird type of stuff. It's like a open pyramid or something. It looks a bit weird. We can probably make it a little bit more normal looking. This is the regular pyramid. It's a, but it's sort of hanging, right? It's kind of nice in that sense. And now we can create a, so we can create a net of this particular object. Sorry?
I was just saying that you can create a net, but you said.
I didn't what? Sorry? Yeah. So
I was just saying that you can create a net.
Yeah, exactly. And you see, this is how the net looks like. It's pretty weird, isn't it? I mean, if I switch off the pyramid, the net actually looks like this. I sometimes call this the dancing god. It looks like someone is dancing, isn't it? This particular figure. Yeah. So anyway, if you do that, you can now sort of open it up and make it into a net. Make it into the actual pyramid. Okay, so it's very important that you sort of look into this kind of objects all the time and try to think about how you can go and invent net of other objects. Now let me go ahead and go to the next type of thing that you should be worried about, or you should be looking forward to. I shouldn't say worried about. So this is the next type of thing is creases on paper. So this is a very famous type of problem, and maybe some of you have already seen this type of problem. We have discussed this type of problem in our level 2 Math Olympiad program recently. So it's like this, that if you have, let's start with a square piece of paper, and you can also draw this in your notebook. So this is an example problem, okay? This is an example problem. Suppose we have a square piece of paper like this. Let's call it A, B, C, D. And what we do is we will fold this thing like this. So about the diagonal BD. So let's fold it about the diagonal BD like this. So if we fold it like that, you can see that there will be a pink, this pink line sort of gives you a crease on the piece of paper, right? When you fold it, makes the crease means it sort of gives a marking on there. So how will it look
Sir,
like?
you take right angle triangle.
Exactly. So we get a triangle like this. Okay. Now let's go ahead and try to fold it one more time. But there is something very special about this triangle. It's also isosceles. What does that mean? That means two sides of this triangle are equal. The length of two sides, because they were sides of the square, right? Square has all sides equal. So clearly, once you fold it, you get this sort of a piece of paper, right? Okay. Now let's go ahead and fold it one more time. So step 2, I want to fold it one more time. So here this time we have this, let's make it in green, a crease like this. We have
Sir, it will become a triangle.
it would again become an isosceles triangle. So we will fold it like this. And if I do that, I am going to get a triangle that's kind of like this. Correct? Okay. So now step 3, I'm going to fold it one more time. So this time I'll be folding it about this red line, the crease one more time. So I will get another picture like this. So I might also
Sir,
draw.
is this another isosceles triangle? Sir,
Yeah,
is this another isosceles
this is another.
triangle?
Yeah, exactly. So you see, I marked this one in green, so I marked this line in green as well, just to mark it like this, okay? And I should actually mark this one in pink because this side was pink, right? I was folding it about pink. So this side is this one. So I should keep on marking this in pink because this has been folded, but this little portion is this, it's here. Okay. So I'm going to mark it one more time. So I folded it about this midline one more time. So if I do that, you see the green will fall on the pink, right? The green will fall on the pink. So we have a pink green side in some sense. And the bottom, actually the bottom one is sort of blue if you want it. Let's say it's blue. So step 3 is that, and finally we have the last step, step 4, where we fold it one last time.
I think you will fold it along the green again or the pink now, and that will turn into the step 2 light. Well, like how the step 3 light looked like the step 1 light.
Okay, what I'll actually do like is I will fold it about this blue segment, and I will get something like this. Okay, now that's the last one.
Sir, it looks like step 2.
Yeah, it does look like.
It looks like step 2.
It does look like step 2. Yes. So now the
step 3 was. So step 3 was another isosceles triangle.
That is right. Yes, all of these steps are giving you isosceles triangles. Okay, so the real question is this, that when you now unfold this piece of paper, totally unfold it, what type of crease will you get on the original piece of paper? So if you completely unfold it, what pattern will the creases create on the original piece of paper?
Sir, will it create a half star?
I think you should try it first, Athar, before responding. Okay, think a little bit. And Akshita and Ayana, please try this. And Chandan Surabhi is here and Pranjal is here. You can also try this a little bit. The question is really this, that if you completely unfold it after the fourth fold, if you completely unfold it, what pattern will the creases create on the actual piece of paper? So I'll give you a little time to think about it, because it will take a little time. And remember, in the original test, in the actual test, you will not have a piece of paper to actually fold and check what's going on. So you have to sort of do this mentally. You have to use your imagination and do this. So take your time, think a little bit about this, and then I'll of course help you.
Yes, sir, I have done this.
Okay, Akshita, tell me what kind of shape will we get?
Sir, we will get uh, triangles. We will get 4 triangles, and those triangles will also be divided into small triangles.
Okay, have you drawn this in your notebook?
Sir, it will look something like this figure right here. I drew this figure here. I think it looks something like this. Sir, I have found it.
Not really, Athar. Think a little bit more. Okay, Akshita, let's see what you have.
Sir, sir, this video is actually flipped. So maybe you are looking at the.
Okay, Ayana is almost right, but maybe she will need to work a little bit more. And Akshita is right because she actually folded a paper and checked. So that's great. So let's see how we can do this without folding papers, because you see, that's the thing that we have to worry about most. We have to check what's going on without actually folding the piece of paper.
Sir, that is good because these are all rectangle papers.
Yeah. Okay. So what we will do is, you see, when you fold this thing in the step 1, we will use a process called reverse folding.
Reverse folding.
Okay. Now let's see how we can do that. All right. So you see,
sir, the name is self-explanatory because
yeah,
it's just the reverse of folding a paper.
Okay. So when we fold it about this green line, suppose we want to go back to the first step, or step 0. So the green line is here. Let's draw the actual green line, the green crease. Okay, so the green crease is here, and if I draw it in the original square, it's like this, right? It's here. Now if you unfold it, this green crease will also be unfolded and continue up to A. Do you see that, all of you? Yes, sir. The green crease will also get unfolded and go up to the point A.
The point A. Or you unfold the creases.
Okay, now let's do the same thing from step 2 to step 1. So from step 2 we will go to step 1. So we have this red crease in the step 2, right? So let's draw this here as well, because this little triangle is like this one, right? Because we folded it like this. So this triangle is the same as this one in some sense. So we can draw the crease here, and now we will be unfolding it in this direction. If we unfold it in this direction, this red line will be here. So this tip will go here, it will unfold it, and this line here will go here.
So it will go all the way till the midpoint of A and B.
Okay, now if I go back from step 1 to this original square, let's see what happens with the red one. Yes?
It will move to the midpoint of the line AB.
Okay, so let's see that. So first of all, let's draw these two things here. Let's draw these two lines here, because you see, This triangle is same as this one, so we can draw it here.
Okay. Sir, after just putting all its creases, the image will come something like this.
Okay, let's see. I think we can go back to the sharing of the screen one more time because it sort of went away. Okay. Okay, so quickly one more time. So we have this square, we have the first pair, we have the first crease, green crease here. So, and the pink one was here. So pink crease is this one. What we did is we unfolded the green one and we got this.
And your screen is not visible.
Oh, it's not visible. Just a second. Here we go. Can you see it? Okay.
Yes, sir. Now I can see it.
Okay. And then we have the pink
Red
and
crease.
the blue green line, and we can join this, and then the crease was red, so we drew the crease here and then we redrew the crease here. Now if we unfold it one more time, we will get the red crease here and here as well. That's after the step 2 or the second fold. Now if I do so after the second fold, we have this picture. So after the first fold we have this picture, after the second fold we have this picture. Well, actually after the third fold we have this picture. So up to the third fold we have this one. Okay, now in the fourth fold we will just draw this blue line. So we got, after the fourth fold we will get sort of this, but here there will be the blue line. And let's draw this in the original picture. So this one will be here, this blue line will be here. Now if you unfold it, the blue line will also be here. Now let's draw the blue line one more step back, so like this and this, but it's also here and here, and you go back one more step and you get, so let's first draw what we have here, and we can extend it to the other part, so you get the final picture in some sense. Okay,
it's a diamond, sir. It's a diamond.
Yeah. So the most important part of this discussion, and I can think about this as a little bit sort of rushed. I understand this is a little rushed. It's probably we could have done it slower. The main thing is the one thing that I want you to get across from this particular discussion is how you can reverse this folding process and go back to the original pattern by going one step at a time. By going one step at a time, you can sort of reverse the pattern and get back the original creases in the piece of paper that you are working with. Okay, so I think you should, yes, Ayana, go ahead, you have something to ask.
Yes, sir. So my doubt is that if we are making 4 folds on a piece of paper, so it is in the end of reverse folding, so it is giving us 8 triangles. So does it make sense, like twice something?
So, sorry, can you tell me? Okay, so you're saying you're making 4 folds. Since we are making 4 folds, see there are 4 colors of the creases. Do you see that?
Yes, sir.
Blue, red, pink, and green. Each color is actually representing each fold. That's why I color coded it.
Okay, sir.
So that you can easily follow this. You see, color coding mathematical objects is a very useful strategy of learning more about mathematics. Okay, let's go ahead and talk about the next topic, which is moving points. This is a very interesting and important topic actually. you can think about a point P moving in the plane, but it is moving by maintaining some sort of a rule. So,
circular motion.
yeah, it does not move randomly, does not move randomly, it follows a rule. So I'll first go to Akshita because it seems that she has a question. Go ahead, Akshita, you have a question?
Yes, sir. Sir, when we will fold these all, so I'm not able to get that diamond type of thing like that. This I'm not able to get after folding.
Okay. So maybe you can check a little bit and then probably it will work out. Maybe the fourth fold is not coming prominent today.
Okay.
Okay, so it does not move randomly, it follows a rule. So what type of rule will it follow? Well, it depends on the problem that you are doing. So suppose,
Sir,
yes, okay, so okay, so suppose
I have the program of them which is used.
I'm not sure what Atharv is saying, but suppose O is a fixed point and P is a moving point. Okay, now the point P is moving such that the point P is moving such that the length of OP is constant. Is fixed. So if you look at the motion of the point P, wherever it goes, its distance from O is fixed. So you can try to guess what sort of path P will move along.
Sir, like pendulum. Like
What path will
Sir, it looks like a circle.
P move along? Okay, please raise your hands first, then I will be able to ask you to give answers. So the question is, what path will P move along? Let's hear it from Chandan Surabhi Dash because I have not heard from this student for a while. So can
Sir,
you?
it moves like a circle.
It does move
Sir,
like
it
a circle.
looks like a circle.
Yeah, it is a circle actually. This path is a circular path. So this is one way to define what is a circle. If someone asks you what is a circle, you could probably say, well, it's a path of a moving point which moves along a fixed, which such that it's moving and its distance from a point O is constant. Yes. Okay, Akshita, you want to say something? Go ahead.
Yes, sir. Sir, I can't hear you.
Yeah, go ahead, Akshita, please.
So you gave a question at what path will P move along.
Right.
So like if I will move this P from here, then I will just I can't bring it back to a direction, so it will make a circle.
Okay, so yeah, that is correct. You're right. Anna, what do you have in mind? Tell me.
Sir, I was saying that OP is just like the radius of the circle, sir.
That is correct. Yes. OP is indeed like the radius of the circle. That is right. Okay, so that we understand. Now let's do another problem which is quite similar, but I guess more beautiful. So this is a standard type of problem that uses moving points. So suppose this is
The
the,
can you please repeat the circle part? I can't hear you.
I cannot repeat and I will let you go actually because this is very weird. Okay, please go to YouTube and look into the recording of this discussion. All right. So suppose we have a circle like this, and this is sort of the path on which this circle is. Okay. Now let's suppose look at this point P. So we have a straight line on which this circular wheel is there. The red path in which this circular wheel is sort of standing, and this circular wheel is then pushed like this and it starts rolling. It starts rolling. So my question is, if it starts rolling, what will be the path traced out by the moving point P? How will it look like? How will the moving point P's path look like if the circle starts rolling? So you can try to think about it. It's a it's really a pattern recognition problem. Pranjal and Akshita and others have raised hands. So let's hear for Pranjal. I have not heard from him. Tell me, Pranjal, what you have in your
It
mind.
will move like a cylinder.
Not really. What do you
Like
think?
the large machines that we pave the roads.
Uh, Maybe Akshita can tell me what kind of shape we will get.
We will get semicircles.
It's kind of like a semicircle, isn't it?
Yeah, it was a kind. When we will just draw it, we'll see that when the circle will start rotating, the P point will also start moving according to the circle, and by that, it will make a semicircle.
Okay, so let's do one thing. I'll show you a little demo of how it looks like. So it does look like a semicircle. I mean, it's not a semicircle really, but it looks like one maybe. So let's see if I can show this to all of you. Okay. So let's see if I can. Here we go. So I will just add this screen, and here we go. So that's number one, and I will stop sharing this one, and I will share a window which contains this. So I guess all of you can see now my
Yes.
window. Okay. So let's zoom in a little bit. So this is like the circle, okay? And this is the point which I am tracing out, or rather, this has been created by Professor Anand Khandekar, this animation, so we should give due credit to the person who has created this. So anyway, now if I look at this, you see the point, as a circle starts rolling, the point P starts tracing out a very beautiful sort of a path. Now if you, let's say, so I'll do it for 3 times. So once it happens like this, the second time it happens like this, the third time it goes on and happens like this. So yeah, so it's like this. So this particular shape is known as the, and there is a very good question by Aryan Das in the chat. So what would be the length of the circumference of this thing? So what is the length of one such wave? What would be the length of one such wave? That's the question actually.
The diameter?
Not really. It won't be the diameter. If you think about it very closely, you'll see that it's really the entire circumference is sort of opening up. It's sort of unfolding like this, unknotting like this. If you think about a thread that has been,
Sir, half of circumference.
sorry, it's like the entire circumference actually. So entire circumference. So anyway, so this particular shape is known as a cycloid, and there are many beautiful such objects out there which can be studied as path of moving points, so I would strongly recommend you to think about such things, and some of them you have already encountered in the program that you are all, if you are an internal student, you have already encountered it. Okay, let's go ahead and do the last part of this discussion and talk about dominoes. Okay, so strictly speaking, they are not really geometry. I mean, they have some geometric aspects, but they're not really from geometry. They could be like from counting problems. So what are these? So these are like, you have small Lego pieces which you can build, which you can use to build stuff. So I'll give you an example. This box is known as a 1x2 domino. This is a 1x2 domino. Why is it called a 1x2 domino? Can anyone tell me that? What is so special about this picture that makes it a 1x2 domino? Let's hear it from Akshita maybe. Okay, I cannot hear her. Let's hear it.
Yeah. So 1x2 domino means that, yeah. So there are two parts here, and there is a cross over here which we can see. So that is why we say it 1x2.
Okay, let's hear it from Ayana. Ayana, what do you think?
So I think it is called 1x2 because it has one column and means one row and two columns, or one width, two length.
That is correct. That is exactly what it is. So it's one row and two columns, and so these are the columns and this is the row. So in some sense you get an idea about why this is a 1x2 domino. Now suppose if I ask you that I have a picture like this, which is sort of like this. Okay. So, and I will give you a bunch of 1x2 dominoes. You can put them horizontally, or you could put them vertically as well. So you can put it in whatever orientation you want. And can you cover this particular shape, this pink shape, with this 1x2, these 1x2 dominoes? You have unlimited supply of these dominoes. So this is the building blocks. Okay, these are the building blocks, and you have unlimited supply of both kind, the horizontal kind and the vertical kind. And you want to build something like this. You are not allowed to overlap two dominoes. That's not allowed. You are not allowed to overlap two dominoes. That's not allowed. Are you able to sort of cover this entire pink thing? So that's just the shaded region. Okay, so the shaded region. So can you cover, or I'll draw the border using blue actually. So can you cover this blue and pink region with these dominoes? Let's hear it from Chandan Suravi Dash. I see a raised hand there. Maybe he wants to say something. Uh, but okay, let's hear it from Pranjal actually. Pranjal, what do you have in your mind?
I don't think you can except if you overlap one of them.
Okay, why not?
Because every single time you're trying, you are getting like you're getting one hole every like one hole somewhere, and that means you can't put two don two 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 cross two 1x2 dominoes.
Okay, what do you think, Ayana?
So my answer is also no, because I have tried it means from every type, and two blocks means two dominoes are means they cannot be covered through 1x2 dominoes because it has an empty space in between.
Okay, that is, I see all of you are saying it's no, and you're saying that I have tried something and it doesn't work. Maybe you can think of a better argument, because if this is really large, if this board is really large, then you cannot use that argument that I've tried it and it doesn't work, right? You have to say something which is more useful, so more argumentative. So maybe you can think a little bit more about this. But let's say if I ask you an easier problem, can you cover this one with some of these dominoes?
Yes.
Okay.
Yes, sir.
Okay, so how many of those dominoes do you need to cover this one?
Two. Sir, two.
You need two dominoes, right?
Sir, two dominoes.
Now the problem
Sir,
is,
two dominoes.
yeah, so that's great. So you need two dominoes. Now the question is, suppose if I change this picture and I make it like this, like a gun or something. So
Sir, I
can you cover this one with these two dominoes?
No, sir. No, sir.
We can't do it,
No,
right?
sir.
Why
No,
can't
sir.
why can't we do
No,
it?
sir.
Why can't we do
No,
it?
sir, it's not possible.
Why can't we do
Because
it?
sir, because the dominoes go into groups. Now, if I will place them all, so only the two spaces can be covered, and one space will always be left.
Okay, that's great.
The meant is that four dominoes are covered, and one domino cannot be covered from every side, even though I try.
Okay, that is good. But can you sort of give me a general argument in the sense something related to the number of boxes that are here?
Yes, sir. Like yes, because the area.
Yeah, go ahead. Let me hear it from Ayana saying. Let's hear it from Ayana. What do you think, Ayana? Why can't we do it in the case of this black thing?
Sir, because according to me, when you gave us two, means you gave the 2 into 2 dominoes when so it had 4 dominoes, means it has an even numbers of dominoes. So it was divisible by 2, so that is why it can be covered with those 1 cross 2 dominoes. But 5 dominoes cannot be divided by 2. That is why they cannot be covered by 1 cross 2.
You see how wonderful Ayana's argument is. It's very nice, very good. You see, she's using a more fundamental idea of odd and even. She's saying, okay, whenever you put a bunch of dominoes in some picture, you are covering even number of blocks, right? Because each domino contains 2 blocks and you are covering even number of boxes. But this particular picture, this one right here, has odd number of boxes. So no matter what you do, it will never work. But you see, this argument will not work in the previous pink case.
Yeah, because this has 8 blocks and 8 is visible by 2 because it's even and still it doesn't happen. Exactly. Means that her argument is wrong.
No, her argument is not wrong. Her argument is not wrong. It's just that
like it doesn't work in every domino pieces.
So you have to be very careful. What she says is that if something can be covered, at least it has to be even. The number of boxes in that picture should be even. She is not saying that whenever the number of boxes in the figure is even, it will work. She is not saying that. She is saying that if the number of boxes in the figure is odd, it will not work. So that is still true. If this is Ayana's argument, Ayana is saying that if number of boxes is odd, it will not work. You cannot cover it. But she is not saying if the number of boxes is even, you can cover it, because that's obviously false from this particular picture.
Now.
Yeah. So that's a very different thing. So now what I will ask all of you, and you can think about it, what could be a general argument for the pink case? Why would it not work? So I'll not ask for answers right away. I'll let you think. Now, we will stop out here today, but hopefully we'll come back more with these sort of open sessions, which will help you to work with problems which are like this. Okay. All the best to all of you, and happy learning mathematics. Bye.
Bye, sir. Thank you, sir. Bye, sir.
Bye.